Hey, how's it going, everybody? Today we have an amazing problem for you guys called linked list cycle. All right, so it says given head, right? The head of a linked list, determine if the linked list has a cycle in it. If there is a cycle in a linked list, right? If there is some node in the list that can be reached again by continuously following the next pointer, right? So it says internally the pause, right, but the variable is used to denote the index of the node that tells next pointer is connected to. Okay. Note that the pause variable is not passed as a parameter. Okay. It says to return true if there is a cycle in the linked list. Otherwise, return false. Okay. So very interesting things that they're telling us, right? So we'll be giving some kind of a linked list, right? Headed to a linked list, and we need to find out if the linked list has a cycle, right? So that's kind of what we need to do to determine if there's a cycle, right? So if there's some kind of a loop, pretty much, right? That's pretty much what they're saying. Okay. So let's see what's going on here. So for example, for this first example, I think this is gonna help us understand the ask better. Okay. So we're given this linked list, right? Because see, there's a cycle, right? Because we end up looping back to 2, right? Because and then we pretty much forming some kind of a cycle loop, right? There's a cycle, I'm saying. So if we were to loop this, right, we would keep looping, right, and never ending because the tail pointer points back to a previous node, right, and then it's going to keep going over and over nonstop, right? So there's a cycle. That's what they're saying here. Okay. And for this example, right, we see that there's a cycle as well because we see the 2 ends up going back to 1, right? And then 1 points to 2. So there's obviously a cycle, a loop, an infinite loop, essentially, right? So that's why we return true for those cases, right? And for this one, there's no cycle because this one's pointing to null, right? The next pointer of the tail node is pointing to null, right? Which is also the head for this example, right? So pretty interesting, okay? So how can we solve this problem, right? So there's also saying, how can we solve this problem, right? Okay, so the most straightforward way that we can think about is to use some kind of we know that when we are dealing with problems where we have to kind of find cycles or things like that, right? We normally use some kind of a set, right? The set helps us to find cycles by finding duplicates, right? So this is what the set's gonna help us with, right? So we would use the set in this manner, right? We would loop through, as we're looping through, we add the nodes to the set, right? And if we're going, as we're adding, right? We add 3, we add 2, right? As we're going, and if we end up going back to a node that we've already seen before, right? Which would be a dupe, right? Then we know that there's a cycle because there's no way of we would go back to a previous node we've seen before if there wasn't a loop, right? And that's kind of the thing about it, right? Because on a regular linked list with no cycle, right, we would just go straight through, right? 3 points to 2, we could loop through, and then we would, the last node, the tail node, right, would point to null, and we would know that there's no cycle in that linked list, right? But the ones that do have cycles, we loop back again to a previous node that the previous node in the linked list, right? And that's how we end up in this infinite loop, this cycle, right? So that's how we would use the set, right? As soon as we've seen a node that we've seen before, we just say, all right, cool, there's a cycle there, right? So that's kind of how it would, right? That's the straightforward way, easy way to brute force, right? The easy, intuitive way that we can come up with, right? So what's kind of a better alternative that we could do? Can we improve this thing, right? So I'm going to introduce you guys to a very important algorithm that you guys need to make sure that you guys have in your toolkit, right? So that you can solve other problems similar to this problem, right? So the algorithm is called the floor, tortoise, and hare algorithm, right? So it's a very good algorithm to make sure that you have in your tool belt, right? So the gist of it, right? Now, this algorithm is very helpful in finding cycles in a sequence of values, right? So this is a very important algorithm that I'm about to show you guys, right? So how it works, right, is we have 2 pointers, right? 2 pointers, one that goes so 2 pointers, right? So The reason why is so one's gonna be going regular speed, right? You know, one at a time, and one is gonna be going twice as fast, right? So as we do that, guys, right, so as we're traversing, right, we're looping through, right, you know, so one moving one at a time, right, and one that's moving twice as fast, right? So instead of going to this one, it goes to that one, right? And it keeps doing that, right? So as they're moving, looping through in the linked list, right, if they ever intersect, right, if they ever intersect, then we know that there's a cycle, right? If they ever intersect, right? It's kind of how this algorithm is very helpful into make sure that you know this, right? If you've been exposed to that, right? So this algorithm works in a lot of different problems as well. When we have to deal with sequence of values and we need to find cycles in the sequence of values, right? So very, very important that you guys have it, right? So that's kind of what it is, right? We just two pointers. We start initially, right, and then we move the slow pointer, one step at a time, and then we move the fast pointer twice as fast, right? And if at any time they end up intersecting at any node, right, you know, so if there's no cycle, right, the fast pointer is going to get to the end, and it'll never intersect with the slow because slow is moving one step at a time, right? But if they end up meeting, right, because there's a cycle, because you know, by the time this gets to here, right, it's going to loop back again to this one, right? So let's just do a quick example. So yeah, let's do a quick example so you guys can understand how it's going to work, guys, right? So we have two pointers, right, initially pointing to the head, right? And then now what we're going to do is to move the pointers, right? So I'm going to move the slow pointer one step at a time, right? It goes here. And then the fast pointer, right, since the fast pointer moving twice as fast, it skips this one, it goes to here, right? And then once we're here again, right, we move one step at a time, we move slow again. And then you know, we also have to move this again, right? So now the next position of fast is going to be here, right? Because it moves twice as fast. So it skips this one, it goes directly to that one, right? So boom, goes here, right? And the slow again is gonna end up moving one step at a time, moving super slow, right? Like a tortoise, right? And then the hair is going to be moving super fast, right? It's gonna go here, right? And then they intersect. Then because of that, right, we just return right away that this is there's a cycle because they end up meeting again, right? Which shouldn't be the case, right? So let's go back into the code. So yeah, the code will be a lot more simpler, right? So what we're gonna do, we're gonna start with the node, the initializing nodes, right? So they're both gonna be pointing to the head, right? So the fast pointer and the slow pointer will both point to the head, right? And then we're gonna be looping through the list, right? So we're going to be doing that while fast is not null and fast that next is not null as well, right? So make sure that you guys understand that, okay? And what we said, we're going to move the fast pointer to be twice as fast, right? So fast that next, right? So moving twice as fast, it's in a hurry, right? It's here, okay? And we're going to have the slow pointer to move regular speed, right? Slow that next, okay? So very, very, very classic two-pointer technique, right? So one moves twice as fast, one moves regular speed, right? And if we ever end up, right, meeting, right, so they're slow and the fast pointer are both pointing to the same node, then we return true right away to know that this is there's a cycle that exists, right? Because if there was no cycle, then we would never like meet because fast is moving twice as fast, right? So the slow should be in the rearview mirror, right? So, but if they end up meeting any point, they will return true to the cycle because it means that we had to go have gone back, right? It means that, you know, we probably went back and, you know, yeah. So if we never go back and we exit out the loop, then we are good to go, right? So let's press run code to prepare the small test case. All right, press submit. Awesome, guys, we're able to pass all the test cases, guys, right? So if you guys found value, you guys enjoyed the video, make sure to let me know that in the comment section. If you guys are new here, subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.